So we're going to finish lesson 23. In lesson 23, we began to talk about reference angles. Reference angles. And when we're talking about reference angles, we're going to talk about angles whose measures are less than or equal to 90 degrees. Normally we're talking about acute angles, but we will also use quadrantal angles and associate a quadrantal angle with another quadrantal angle. So in reality, a reference angle is really not a 90, it's really acute, but we're still going to use the same sense in doing that. When we talk about a reference angle, there's four places that we could be and be acute, and I'm just going to kind of redraw my lines like this. If I drew a line like this, and I'm going to just try to make it the same, and we're really dealing with acute angles, then we could have this acute angle that's right here, or we could have this acute angle that's right here, or we could have this acute angle that's right here, or we could have that acute angle that's right there. When we're talking about a reference angle, we're talking about between the terminal side and the x-axis, okay? Between the terminal side and x-axis. And what we're really saying is, if I went from what's supposed to be the initial side of any angle, which is the positive x-axis, I'm going to let that go away. It'll go in a few seconds, I think. I'll do it that way. If I were to start here and go all the way to here, then what I've got is an obtuse angle. But what I would like to know is what is the reference angle associated with that obtuse angle. And the reference angle associated with that obtuse angle is going to be the acute angle that is formed by its terminal side and the x-axis, you see, which would be that acute angle. Well, how could I get that? Well, it's going to be all of the semicircle 180, right, minus the original angle. If this original angle was theta, then that little angle is 180 minus the big one, right? Okay? So if we're looking for the reference angle to an obtuse angle that ends right on this side of the x-axis, then to find its reference angle, we're going to do 180 degrees minus the original big angle. Okay? And then we're going to say, well, what would happen if instead of that, my original big angle went all the way to here? And I want the reference angle that goes with that original big angle. Now this time it went past the axis, but still the reference angle associated is going to be its terminal side and the closest piece of an x-axis, okay? It's the angle formed by the terminal side of that whole big angle and the closest positive x-axis. We're talking about this angle. Now, how are we going to get that little angle right there? That little angle right there. How are we going to get that? Well, we're going to take 180 degrees away from the original big angle, right? If we want this little piece, we've got to take 180 out of all the way to here. So in that situation, we're taking away the 180 degrees from the original big angle. So if we want the measure of a reference angle in this position, then to find it, we're going to do 180 degrees minus the original angle. But if we want a reference angle for this position, we're going to take the angle minus 180 degrees. If we want this angle right here, it's just the angle we started with. You see, we didn't go over close to the other side. But if we went from maybe I'll do this in red. If we started here and we went all the way to there, and we wanted the reference angle for that whole big angle that's almost the whole circle 360, then the reference angle would be its terminal side and the closest piece of an x-axis, which means we're dealing with that angle right there. Well, how do you get that? It's the whole circle, take away this big old chunk, right? So if you take that big chunk, which is our angle theta, away from the whole circle 360, you're going to get that angle right there. So a reference angle in this position is calculated by just taking the angle theta itself. A reference angle in this position is calculated by taking 180 minus the original angle. A reference angle in this position is calculated by taking the angle minus 180. A reference angle calculated in this position is calculated by taking 360 minus the angle itself. And I gave y'all a worksheet like this. Y'all see this worksheet? Obviously, those who are listening to this recording are not going to see this worksheet. I apologize. I haven't scanned it so I can pull it up for people to see yet. But if you notice on the left side, it has reference angles. So there it is to memorize. This is just a summary of some important notes. And you can look over here at this board over here, and you can see that we've got it here too. What's on this board is an accumulation of some fundamental things we're going to need. And on that sheet of paper I gave you is a accumulated list of some fundamental things we're going to need. And then we're taking notes over some other stuff that isn't trying to build on itself as much. It's some foundational work. So this is going to become very important to study. All right, that's all of the new information that you need to be able to do Unit 5.1 in the pre-cal book or Lesson 23 on our course syllabus. But we haven't really worked a lot of problems. So what we're going to now do is work the problems off of the worksheet that I gave you. And I'm going to write these problems down on the board. But you'll see that they do reflect the work off of page 281 to 282 of the textbook, which is Unit 5.1 homework. And the directions are the same, and they're actually some of the odd ones from those pages, okay? Just so we understand how to do that homework. And so question number 1 on your lesson 23 to 25 worksheet says change each measure to degrees, minutes, and seconds. And so we had 24.25 degrees, and we want to change that into degrees, minutes, and seconds. Now, here's what we need to know. We need to know that 1 minute is equal to what? 1/60th of a degree, correct? And we need to know that 1 second is equal to 1/3600th of a degree, which we know in the middle of that 1 second is also 1/60th of a minute, right? And so we learned that a degree is really, by size, 1/60th of the measure of the angle of an equilateral triangle. Each angle of an equilateral or equiangular triangle is 60. And so the size of 1 degree was assigned by the Babylonians as being 1/60th of that amount, that size. And then when you divide that by 60, we get 1/60th of a degree, and so we just call that a minute because that's something we're familiar with the clock. And when you take 1/60th of a minute, then we call that a second. And so if we want to convert from degrees to minutes, let me just show you what we did with dimensional analysis. And I want to do it with dimensional analysis a little bit too. I'm going to do it over here at the side, and then I'm going to do it different. We said that if we've got like negative 24 degrees, So we've got negative 24 degrees, okay? But we want to take the decimal amount of degrees, and we want to change it into minutes. Now, here's how we would have done it with dimensional analysis. We would say, okay, I got 0.25 degrees. And I want to multiply such that I, how do we say that in science class? Lose, have y'all done that, dimensional analysis? Lose the name degree and gain the name minute. And so then we would say, well, one degree is 60 minutes. See, some people have trouble knowing whether you're supposed to multiply or divide by that 60. You see how dimensional analysis straightens this out? 0.25 degrees change to minutes. We want to lose the name degree. See why that works? Lose the name degree, gain the name minutes. 1 degree is 60 minutes, so we multiply by 60. You could say we're going from a larger unit. I'm writing that backwards. We're going from a larger unit degree to a smaller unit minutes. When you go from larger to smaller, you multiply by the conversion factor. Okay, so you could say that. I like dimensional analysis better. So if you do 0.25 times 60, what do you get? 15. And we show minutes with one little ditto mark. 2 little ditto marks mean seconds. There was no remainder of minutes, so that's the answer. So we change this from degrees into degrees and minutes. Everybody see what we did? Using dimensional analysis, okay? Number two, we have 39.875 degrees, 39.875 degrees. Now, we know that the 39 degrees is 39 degrees, but we have a decimal left over. And really what we're doing is that dimensional analysis stuff, right? We're saying I'm going to move this. We're saying I need to change that 0.875 degrees into minutes. So I need to lose the name degree and gain the name minutes. This is the dimensional analysis approach. You understand that? I'm going to do that a little bit just to make sure we understand dimensional analysis. And so that would be gone, but then we say, well, what's the conversion? Well, 1 degree is 60 minutes. So what we see is that we need to multiply 0.875 times 60. Now, if we do that, and somebody do that for me, sometimes when I go to my calculator, it doesn't let my writing come back to the screen. So somebody do that for me right quick. 0.8. So we're going to get what? So we're going to get 52.5 minutes. Everybody see that? So what we have now is 39 degrees, 52 minutes, but we have some leftover minutes. Well, how many leftover minutes do we have? 0.5. So we need to do this again. We're going to say 0.5 minutes. And we need to change that into what? Seconds. So we need to lose the name minutes and gain the name seconds. And we know that 1 minute is 60 seconds. And those names minutes are going to cancel. And so you're really saying 0.5 times 60. And so we're going to end up with 39 degrees, 52 minutes, and 30 seconds. Degrees, minutes, and seconds. So we went from degrees to degrees, minutes, and seconds. Obviously, we're going to learn you multiply by 60, multiply by 60, multiply by 60. and not have to show the dimensional analysis, but we need to understand the dimensional analysis. It's very important to other applications of math and science. Any questions on number 1 and 2? Now, in that particular case, we went from degrees to minutes and seconds. Now we're going to go from degrees, minutes, and seconds just to degrees. We're going to go back and put it in a decimal form. So we're doing the same thing, only we're just kind of going backwards. And I'm going to show it to you with dimensional analysis also, but obviously once we do that, you're going to say, well, I could have just done that. I could have just multiplied. But we still want you to see it. So question number 3, we've got 46 degrees, 23 minutes, and 46 seconds. Now, we want to put it in degrees. Now, so what we need to do is we need to change the 46 to degrees, but it's already in degrees, so we're fine there, right? We need to add to that the minutes and seconds converted to degrees. Now, I'm going to come over here to the side. If we had 23 minutes, and we were going to use dimensional analysis, to change it to degrees, we would say, I want to lose the name minutes and gain the name degrees. And I know that 1 degree is 60 minutes. And so now I'm not really multiplying by 60. I'm multiplying by 1/60th. And we learned that when you go from a smaller to a larger, you really divide instead of multiply. So what I'm going to do then is take those 23 minutes and I'm going to multiply by 1/60th to change them to degrees, right? And then I've got my 46 seconds. Well, how many seconds are there in a degree? 3,600. If I did this by dimensional analysis, we would be saying 46 seconds, and I need to change that to degrees. Whoops, sorry. I need to change that to degrees. So I need to lose the name seconds, gain the name degrees, and 1 degree is 3,600 seconds. So what I'm really going to do here is multiply by 1/3600th. Understand that? So I've got 4 degrees, 23 minutes, so there's 23 1/60ths of a degree, plus 46 seconds, which is 46 1/3600ths of a degree. And when you put all that in the calculator and hit enter, you get 46.3961, whoops, rounded to the nearest thousandth, 46.3961. And it says there, round to the nearest thousandth, tenths, hundredths, thousandth. How about 46.396 if we're going to go to the nearest thousandth? Somebody didn't read the directions. All right. Thousandths is 3 decimal places. Everybody say we did that? And we can put our degree symbol. All right. Number 4. So I won't do all that over there again. That dimensional analysis stuff, we've got that figured out, I think. And so number 4, we have negative 28 degrees, 14 minutes, 7 seconds. So we're going to have our negative 28 degrees. I'll just leave that off right now. Plus, now if you're going to put a plus, you're going to have to put plus a. See, the whole thing's negative. Y'all understand that? So if we're going to put plus, we're going to have to put plus a negative. And normally when we put plus a negative, we put a minus. See, everything's negative. So we want this to be negative and this to be negative and this to be negative. And we're going to combine like terms. So 14 minutes at 1/60th of a degree apiece minus 7 seconds at 1/3600th a piece. And when you multiply that out and hit enter, you get negative 828.35 rounded to the nearest thousandth. On my answer key, I rounded to the nearest 10,000th. I didn't read the directions good. Any questions on 1 through 4? We went from degrees to degree minute second, and then we went from degree minute second back to degree. What I'm going to try to do as we do the homework is give you the rules and then give you the drill, basically, if I can. Okay, is everybody good through number 4? All right, number 5. Number 5, it says give the angle measure represented by each rotation. Now, remember, clockwise, first of all, it goes that way, and second of all, what do you know about that? It's positive, right? That's counterclockwise. Thank you. Counterclockwise is that way, and it's positive. Clockwise is that way, which would make the angle negative. So we have to know that. And when we're talking about a rotation, we're talking about how much? 360 degrees. So, for number 5, you've got 2.5 rotations clockwise. What does it mean you're going to do? 2.5 times 360, but it said clockwise, and clockwise is negative, so we multiply by negative 360. We're going 2.5 rotations in a clockwise direction, so we have negative 360 times 2.5 is negative 900 degrees. Any questions on that? Number 6. Number 6 says 3.25 rotations counterclockwise. Now, how much is a rotation? 360. Counterclockwise is positive, so we're going to make that a positive 360. So 3.25 times positive 360 is 1,170 degrees. Okay? So we're determining the degree of an angle based on its number of rotations and the direction of rotation. Okay? Any questions so far? I'll let everybody catch up. Everybody good there? All right. Well, let's look at the next thing. It says identify all angles that are coterminal with the angle and then name one positive and one negative angle that is coterminal with the angle. Let's just say that our angle is theta degrees. It's really supposed to be a little more oval than that. If my angle is theta degrees, then the set of all coterminal angles is what? Theta plus 360k, where k represents a positive or negative integer, right? That means we could rotate clockwise or counterclockwise. I tried to mess that up with the k the other day. So if we wanted the set of all coterminal angles, it would be 0 plus 360. So to get a coterminal, all you have to do is add 360 or subtract 360, right? That's all you got to do. Add 360 or subtract 360. And so, number 7. Number 7 says, identify all angles that are coterminal. So what would that be? The angle theta, we're just plugging into our formula, right? The angle theta plus 360 degrees K. That's the set of all angles coterminal with that angle. Okay? Now, what if it said name a positive one and a negative one? How would you get a positive one? You would add 360. If that's enough to make it become positive. And how would you get a negative one? Subtract 360. If you added 360, you would get 249 degrees. If you subtracted 360, you would get negative 471 degrees. So here's the answer. The answer to the set of all coterminal angles is this. The answer to name a positive one is that one, or 360 more than that, or 360 more than that, or 360 more than that. And the answer to name a negative one is that, or 360 less than that, or 360 less than that, or 360 less than that. Any questions on that? So we named the set of all coterminal angles, and then we named one positive and one negative coterminal angle. Any questions? Okay. So number 8. Oh, tell what quadrant each angle is in. Thank you. What quadrant is 249 degrees in? Well, let's just look at that. This is 0. This is 90. This is 180. This is 270, right? If we rotate in a positive or counterclockwise position 240 degrees, we're going to be in quadrant 3. So that 249 degree positive ends up in quadrant 3. You see that? Now what about that negative 471? Well, what if we go from here clockwise 360 degrees? That puts us to there, right? So let's take that out. We kind of knew that, didn't we? So we got another 111 degrees to go in the clockwise position. Now, if we go that way, then this would be 90 that direction, right? So 110 would put us somewhere in here, and it's in quadrant 3 also. We just went a different way of getting there. Okay? Do what? Yes. Yes. And so that's what, coterminal means. They should, I shouldn't have made this here and here. They're going to have a common terminal side, right? They should have hit at the same place. Thank you. That was weird that I didn't do that. We're talking about coterminal angles. They have to end up on the same place, you know. Thank you. So they both had to end up in the same quadrant if they're coterminal, right? Very good. All right, any questions on number 7? Y'all keep me on my toes. Sometimes I'm up here, I'm recording. It's kind of keeps you a little nervous, but anyway. And I will make mistakes in trig more than any other subject. It's so easy. You let your guard down. So when you observe something that we need to interject into the lesson, be sure and tell me, because we don't want to miss those things. It's like that was the obvious, and my brain was already on the next problem. Let's look at number 8. Number 8 is 23 degrees. That's our original. If you want the set of all coterminals, we're just using this formula, the angle plus 360K. So it's 23 degrees plus 360K. That is the set of all angles coterminal with the 23 degree angle. Now, if we wanted a positive one, then what would we do? Add 360, or 360 plus 360, or however many 360s we wanted. And if we wanted a negative one, we would subtract 360 degrees. So a positive one could be 383 degrees. And a negative one would be negative 337 degrees. The original one was 23 degrees. Where's every one of the others going to end up? Same place. That's the whole concept of coterminal. We should not have missed that at all in our thinking, right? And so if we went 383 degrees, there's 360, 83, same terminal side, still in quadrant 1. If we went negative 337 degrees, we would start here, but where we're going to end up? Same terminal side. Still quadrant 1. Better be, huh? There we go. Any questions on finding coterminal angles? It's kind of weird that I missed that little piece. Thank you. Any questions on the first 8? Now we're going to take a look at those reference angles. Reference angles. Now, when we're talking about a reference angle, we kind of got to think about where we're going to end up. Remember, this is 0, and this is 90, and this is 180, and this is 270, and this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And if we say 410 degrees, we're going to think 410. That's all the way around. We're on number 9. But I'm going past all the way around, so how much is left after that? Well, I can subtract 360 and get 50. So I'm going to go all the way around plus 50 more. And so here's my terminal side. And here's the closest x-axis. And if we take that whole thing minus 360, then we're at 50 degrees. So the reference angle to 410 degrees is 50 degrees in quadrant 1. Y'all see how we got that? Which means if we were in this position, see on the whiteboard over here, then we could get it by taking the angle minus 360, right? Now, it's really the angle if we just gone this far. But if we went all the way around, it's the angle minus 360 degrees, which we didn't put in our notes earlier. So if you're going to go all the way around it, then you're really doing that, right? Okay, and then let's look at number 10. Number 10, it had negative 395 degrees. The answer is 50, yes. So the reference angle, remember a reference angle, we want to be less than 90. And we're going to go from its terminal side back to the nearest x-axis and figure out what that angle measure is, and that's our reference angle. From its terminal side back to the nearest x-axis, yes. The question is, will reference angles always be positive? And the answer is going to be yes, because what we're going to do is we're going to say, okay, the reference angle is 50, but then we're going to learn later that sine, cosine, and tangent are all positive in quadrant 1. And then we're going to learn that sine is positive in quadrant 2, and tangent is positive in quadrant 3, and cosine is positive in quadrant 4. And we say A, smart trig class, to remember that. So you don't really have to know if it's positive or negative. You just need to know what quadrant it's in, because we're going to know whether sine, cosine, and tangent are positive in every quadrant. So that's how we'll determine if the final answer is positive or negative. Okay? So anyway, yeah. So when we talk about a reference angle, we're going to be talking about a positive angle measure. The result may be negative depending on what we're trying to deal with. Any questions on what we've done so far? Okay, so if we think about negative 395 degrees, if we were to actually kind of add 360 to take a circle out of it, we're actually going, you realize, in a clockwise position. We've gone all the way around. That means we need to go in that direction another 35 degrees, right? So that means we've gone from here, 360, and it put us back to the axis, and then we went 35 more degrees past that axis. And so there's my terminal side. And if I'm going to go back to that closest x-axis, then there's my reference angle. So my reference angle is that angle. Well, how would I get it? Well, you can look at our notes. What did we do? We actually said in our notes, you're going to take 360 minus the angle, right? We said to do it like this. Take 360 minus the angle, and you're going to get negative 35 degrees. But all that's really telling you is you're going 35 degrees in the negative direction. Now the reference angle is 35. The negative just told us which way to go, you see. Okay? But you do need to know which way to go, so you know which quadrant you end up with. Yes, sir. The angle is negative. So if you took that minus the angle, it'd be minus the negative, which is a positive 700 and something degrees, right? But in reality, we're really just looking for, we're really, okay, I'm making a mess out of this now. No, you're good. You're right. You're right. What I'm doing is I'm doing it in the picture, and then I'm doing it with the formula, and I'm trying to make my picture match my formula, and I'm making a mess out of this thing. You're right. Wow. All right. Sorry about that. Let's rewind. If I want it to turn out positive, then what I need to do is I need to add 360s until it turns into positive, right? So if I add 360, I'm still at negative 35. That means I would really need to add 360 again if I'm going to make it positive. And if I did that, then that would make it 325 degrees positive. If I go 325 degrees positive, I'm still going to end up right there. Right. And so the reference angle, if I go all the way back around, is the positive version of that, which is 360 degrees minus that positive, which is back to 35 degrees. So you think, well, how do you do it? Do we move this forward until we find a coterminal angle like it that's positive and then take it away? Or do we think, okay, I'm going to use my formula, which is 360 minus theta, which is going to give me something weird? So if you did absolute value theta, then you would be fine. Right, right. Um, so the way I normally do it is I normally just say, okay, I'm going to take my 360 out of it, and I'm going to understand the reference needs to be the positive value of that. So I'm looking at that little angle right there, okay? I mean, that's what I'm going to do in my head. I'm going to say, I went around and around, and so now where am I at? Well, I'm setting over here, and how far is it from that axis? Well, if I take that rotation out I went past, so I need to take 360 out of it, which gives me that negative 35, but I want it to be positive. So any questions there? All right, so my reference angle is going to be a positive acute angle. It's going to be a positive acute angle. And when you look at that trig chart on this whiteboard over here, that's what we're going to be dealing with, is positive acute angles to go with. And then we'll look at the quadrant that it is in and whether they're all sine, cosine, or tangent is quadrant in that particular angle, in that particular quadrant. Yes. The answer is 35. We want when we're talking about a reference angle, we want an acute angle. We want the acute angle. So if you went this direction and you added 360s until it became positive, then that would tell you that we're setting here. So then to get that, you're going to do 360 minus that, which is going to give you the 35. Or you're just going to have to think about taking a positive 360 out and seeing where that puts you. Kind of think backwards a little bit. All right, appreciate your attention. Thank you.